The story of Christmas features a miraculous astronomical sight.
Yes, it was the Star of Bethlehem which shone so brightly.
But this Christmas, we're blessed with an abundance of new visions from the skies. Jupiter and its rings, 385 million miles away. The Carina Nebula, 7,500 light-years away. The Phantom Galaxy, 32 million light-years away. And the deepest regions of space, 13 billion light-years away. These pictures come from the James Webb Space Telescope, which lifted off on Christmas Day 2 years ago.
Liftoff. James Webb begins a voyage back to the birth of the universe.
In 1989, NASA began thinking about a successor to the Hubble telescope. The new machine would have massive gold-plated lenses that could detect infrared light, invisible to our eyes, but capable of passing through dust and gases from 100 times farther into the universe. The Webb would also be much bigger than the Hubble, 3 stories tall and 70 feet wide. Too big to fit into any existing rocket. NASA's solution? Fold it up. How complex is this unfolding process?
They have things that are called single-point failures, right? This has to move this way, and there's only one of them. And Webb has over 300 of those. The light goes from here to here to here.
Scott Willoughby oversaw the Webb's construction at Northrop Grumman. We first met 10 days before the launch. 300 things that have to go exactly right.
Correct. Yeah.
So now, on the 2nd anniversary of the launch, we can finally ask, so how'd it go?
It literally went perfect. As close to perfect as one could have even imagined.
It just seems improbable given that moving parts are always hell.
Yeah. People actually asked after, did you overblow how hard this was, right? And the truth was, practicing for everything as if it could go wrong was the best preparation for making it go right.
It took almost 7 months for the telescope to unfold, calibrate, and reach its orbit 1 million miles from Earth. And because infrared is a form of heat, it also had to get cold, minus 400 degrees. Even the sun's heat would blind the telescope to the faint infrared signals from space.
So we have to block out any shred of that sun by deploying a big sun shield, a big umbrella effectively. There's only one star in the entire universe we'll never see, and it's ours. It's the sun.
Finally, the science could begin.
This is the flight control room. This is where we talk to the telescope. We're telling it, hi there, anything unexpected happened. Send us all the sweet, sweet data that you've been collecting over the last several hours.
Jane Rigby is the Webb's chief scientist. She works at NASA's Space Telescope Science Institute in Baltimore.
The elevator pitch for the Webb telescope was to get the baby pictures of the universe, right? We have delivered exactly what we promised on that topic. We've gone from basically ignorance about what that first billion years of the universe was like to having it in crisp, high definition.
Another Webb mission to examine distant planets to see if any of them have atmospheres like ours, maybe to find one we could live on. But how can a telescope know what's in a distant planet's atmosphere? Turns out, when a planet passes in front of its star, the elements of its atmosphere, oxygen, nitrogen, whatever, block specific bands of light.
And by analyzing how the rainbow changes when the planet is in front of the star, we can tell you what the atmosphere of that planet is like.
The Webb has already studied the atmospheres of dozens of distant planets. It found carbon dioxide and methane on this one, which suggests that it has oceans.
It's such a joy that this telescope is working so well because it was built really well by the engineers.
But not all the Webb headlines have been triumphant. The one in June 2022 didn't sound good at all. Webb's been hit by a meteorite, made a hole.
Yes.
What was that day like?
Yeah, it was wonderful, you know. So we designed the mirrors to get hit by micrometeorites, you know, small particles, say grain of sand or something like that. But I mean, you're truly talking about one small spot and something 22 feet across, right? The impact of it was really irrelevant. It actually didn't impact science at all.
But there were also some questions about the photos. Was NASA manipulating them? Colorizing them?
That question actually comes up a lot. Is what Webb sees real?
NASA image experts Joe DePasquale and Elisa Pagan can answer the questions about colorizing. They're the ones who do it.
It's our job to be able to translate that light into something that our eyes can see.
As it turns out, there's a lot of light that people can't see, like ultraviolet light, which bees can see, or infrared light, which pit vipers can see. Ultraviolet light travels in very short waves. Infrared waves are much longer, and that's what guides the colorizing process.
We're taking the shortest wavelengths, applying the bluer color, the middle wavelength, that's the green, and then the longest wavelength gets assigned the red. This is what we think is the truest representation of what we could possibly see if we could see an infrared light.
If you're that viper that can see infrared.
Right.
In just the first year of Webb observations, scientists published over 600 papers based on its discoveries. And according to Scott Willoughby, the telescope has one more little gift for us this Christmas.
When we launched, we never had to correct our own rocket engines. We saved all of that fuel and effectively on day one doubled the launch of the mission from 10 years to 20.
Wait a minute. So you told Congress that this thing would run for 10 years?
That's right.
And now you're saying we get another 10
That's
for
right.
free?
We used zero contingency fuel, and that leads to 10 more years of operations.
So for at least 20 years, scientists around the world will keep peeling back the mysteries of the universe. And the Webb will keep sending back pictures that amaze and amuse us. From the optical quirk known as the question mark, to the galaxy cluster that NASA calls the Christmas tree, and beyond.